Alright everybody, welcome back to this new TouchDesigner tutorial on the CopySop and multiple object instancing. So today we're going to delete this project and start from scratch. So if you have not seen the first part, I encourage you to go check it out. If you don't want to, well, you stay with us and we will go through the whole thing once again as we're building a different setup based on the same ideas. So we will do a couple things that we already done, but it's always good to get our fingers rolling. And if you don't just want to skip ahead, go to the timestamp that will make you happy. Okay, so let's start right away with deleting everything as we want to create a new tux, a new component for this project. So let's call it pattern, as that's what we're going to create, patterns. So let's customize this component. So once again, also, this tutorial is more for like graphic design oriented projects. It's not the most real-time approach, even though you can always make it work. So first, I want my resolution for my particle system, which we could call it that way. And I'm going to take an XY component because it just makes sense. Then I want an aspect ratio. So let's grab aspect. It's a float. Let's add it here. And finally, my total samples, which is going to be an integer. I could keep it as a float, but let's just take it like that. So I already know that my resolution is going to be 9 by 16. That's obviously my total samples are going to be 9 by 16. So let's do that right away. So my samples are going to be my resolution X multiplied by my resolution Y, and that's going to be the total of instances or particle in my system, 194. And we can grab the same thing, this whole line, and put it in aspect ratio, as the aspect ratio is the resolution X divided this time by the resolution Y. Let's put this a little more readable. Okay, let's put this in toggle read only, as it will never change again. Let's open my parameters here. Let's grab them here. Okay, as per usual, I'm going to create a GLSL top to start. So in my GLSL top, let's go here and right away, let's pump in our resolution. I'm going to bind them as they will never really change, and they will not change like that dynamically. Okay, this is good. This is good for now. Let's open our GLSL dat here. So even before we open it, we're going to skip a step that we did in the other tutorial, which was to add a math top to correct the aspect ratio. We'll do it right in this GLSL. So in the vector page up here, let's add a U aspect, which is going to be a uniform aspect, which is just a way, a nomenclature to remind that uniforms are variables that are outside the scope of the GLSL. So let's just copy paste, well, reference, let's say, our parent par.aspect in our uAspect variable. Okay, back to our code. Let's import this variable with a uniform. It's going to be a float, and this float is going to be called uAspect. Okay, cool. Let's delete this line. And let's call in a variable which is going to be a vec2, and I'm going to call in the UV variable, and I'm going to grab the vuv.st as it is provided by TouchDesigner and the GLSL top. So a UV coordinate, it needs to be scaled by its aspect ratio. The uv.x goes from 0 to 1, and all the pixels will be uniformly distributed between 0 and 1. But we don't want it to be distributed between 0 and 1, but more between 0 and the aspect ratio, in this case 0.56. Okay, so that's what this line is doing. And then let's put this new UV in our color output. So UV is a vec2 and we're calling it a vec4, so we need another component which is going to be the blue. So we got a vec2 here, float, all this makes up a vec4, and when we save we get this texture. So if we inspect it, so clicked on viewer active and press V to view as points, you can see that those points are now in the same aspect ratio as my image. If I take out this aspect correction here and I save, you see that it gets normalized between 0 and 1. So let's be sure to have this activated. Beautiful. Oops. Okay, so that's all we need for the GLSL sides of things. So let's close everything. Next, let's add a null, and that's going to be the end of our tops or null tops. And let's, because we are in tops right now, let's just do our coloring that we'll use later. So let's bring in a noise. So I don't want noise plus input. I really just want the noise. I just want to grab the resolution. Let's put this in random, and I want to then I want to connect a lookup, and from this lookup, let's connect a ramp. The ramp does not need to be in the same resolution as the rest. Alt-N to create a new null, which I will call null color, and everything's gonna be in nearest pixel, and why not 32 bits? Even though color would not need to be, all this part would not need to be in 32 bits, it doesn't matter. Let's put it 8-bit. Beautiful. So let's bring all this into Chop. So let's use a top 2. We will not be using all of those channels, so we don't need the blue channel or the A channel. And in the crop section, we want to be sure to be inspecting the whole image and not just a row. So let's go to full image. And we're gonna reshuffle them, which means like reorganize our channels by their name. So let's do swap channels by name. So right now, all those channels have been converted to only 2 channels, which are R and G. Let's rename R and G with TX and TY. Cool. While we're here, let's just do this also for the color here. There would be other way to do it. I just find it simple to do it this way. So let's reuse RGB and let's merge it here so we don't have to recall another shuffle chop, which is a kind of expensive chop to invoke, even though it's not going to be cooking. I don't think it's actually going to be cooking, so it's not that important. Okay, so we got 144 samples as we predicted. All this is beautiful. Let's add a null, and we will be adding a ton of stuff, not a ton, a couple of stuff in between. Null instancing. Okay, so what I want to do today is some kind of visuals. Well, actually, I want to redo this visual. So to do this, let me show you how. So let's call a rectangle SOP. So a rectangle SOP has something that I do like, is this round corner parameter. So this can make us do some pretty cool stuff and pretty graphical, pretty visual. Once again, looking for those kind of patterns that we looked at the other day. So let's create all the SOPs we're gonna need. Then we're gonna address the parameters we want to modify with the fetch stamp method, and then we'll bring all the chops into our CopySop. Okay, so first, let's bring in a transform, and this transform is going to be like a uniform scale, just so we can have particles of the right size and be able to preview them easily. Then let's bring in another transform, and this one is going to be most of our stamping is going to be made here. And finally, our CopySop. Oh, yeah, let's delete this and bring in the CopySop. Okay, and let's call it copy stamping. Let's add a null with Alt N and call this one null R for null render. Let's view it. I'm gonna split my window for you guys to see it. I don't think it's necessary on your side of things. Okay, so let's make this a little smaller. Okay, uniform scale, let's drop this to 0.05, something like this. Quite small, but we'll see it better in a couple minutes, couple seconds even. Okay, so first of all, let's bring in back our parameters that we've prepared, our samples here, and let's reference it in our CopySop. So reference, 144 copies. So 6,000 points. Right now we only see one because they're all being stacked on top of one of each other. So that's why we're not seeing them. But let's reference our null stamping, not null instancing, so we can see all of our 144 iterations. Instance. Okay, so stamping inputs is on. Let's open up a couple as we want to do TX, TY, TY. Yeah, let's start by those two and then we'll go add all the other ones. So, if you remember from last time, we need to call in those channels and each of those specific samples. So first, let's grab null instancing. So let's call this. Whoop. So the operator is null instancing. Let's just do it the right way, like this. Then we want to, with square brackets, call the right channel, in this case TX, and the right sample of that channel, which will be an integer that it will be called me.copy.index. Okay, let's do the same thing for TY, and nothing is changing right now because we did not fetch stamp anything. So let's see this fetch stamp in action. Let's put this guy a specific color because it's an important one. So let's do all our fetch stamping right away. So we're going to use this method fetch stamp with a default name as the first, the name as the first parameter and a default value as the second parameter. So you see already it has appeared here. So fetch stamp, and we're going to call this one TY. Okay, beautiful. Then uniform scale, let's do this one too. So this one is going to be for us to be able to control the uniform scale, but we're going to call it P scale for particle scale, and as a default value of 1, so we can keep on seeing things. Okay, another thing I want to be able to control is in my rectangle. Here is my corner radius. So fetch stamp, and let's call it CR for corner radius. CR with a default value of 0. Yes, for sure. Excuse me, I forgot to do, I want also to do the rotation on the Z axis. So RZ with a default value of 0. Okay, I think I've got everything. Yes. Okay. Cool. Oops. Oh yeah, and the colors will come back to that near the end, just because you'll see. Okay, so I'm gonna branch out a new branch because I want to merge everything back in just a bit later. So first, let's call in random. This random is going to go from with a pattern chop, excuse me. With a pattern chop, it's going to go from 0 to 1. And that's beautiful. That's what my heart desires. And first, let me, I'll recall this one right away, CR for corner radius. I'm going to bring in a math. And I don't want it, as we can see here, if I go too high in my corner radius, it kind of like, it breaks it. So I want to go up to maximum 0.5. So my channel CR for corner radius has to go from 0 to 1 to 0.5. And this is going to be a null, which will be plugged into the merge. Let's make us a little more space here. Okay, then what else do we have to do? We have to prepare. We have to prepare our scale. So I want everything to be driven by the same randomizing values. So let's bring another math. So this one, we will rename it P-scale in a minute. I want it to go from, let's say 0.5 to 1.5. No, 1.1 for now. Eventually might pump this up. Okay, there's maybe too much variance for me in this pattern, in this random pattern. So I'm gonna use a limit. Let's go to the quantize tab, put it to round, and let's round up the value to 0.1, right? If I round it to 0.5, we only have 2 potential values, 0 or 1. To 0.1, we'll have 10 potential value, 0.1, 0.2, 0.3, 0.4, etc. Okay, this is good for me. Let's rename it to P-scale and connect it in the merge. Let's do something quite similar. So this is for the all of this is for the P-scale. You know what? I'll rename it earlier like this. When I look at my chops, I know what I'm looking at. Next, I want to change my rotation values. Well, I want to create my rotation values. So let me bring in a rename again. So middle click to start a new branch of your chops or of your network. And let's rename this to RZ. Once again, let's bring in a math to change the range. Just here, we're going from 0 to 1. And now I want to go maybe from minus 180 to 180. Okay. And let's bring in, once again, a limit. And let's quantize, round it to 45 degrees. So I want each one of my instances to orient by 45 degrees steps. Okay, let's put this all in the merge. And now, so let's do it right. Let's connect all both of those streams with another merge here. Let's plug this in and then we'll make it move around, okay? So we've got corner radius, we've got P-scale, and we've got RZ for rotation on the Z-axis. Is it CR or RC? I never remember. Okay, it works. CR. So everything disappeared because our P-scale is at a value of 0, I guess. Yeah. So let's copy this, and copy this. And let's change the name of the channels we want it to be influenced. So CR is going to be CR. P-scale is going to be P-scale. And RZ is going to be RZ. Okay, so our CR is me.copy index. It's not having the exact, moving the right way, I would say. Is it really CR? Oh, when I showed you like that, if we go too far, we'll break it. Let's just activate the fetch stamp, and right away we have this already pretty cool looking pattern, which I like a ton. Okay, now I want to make it move, but I want to make it move in like a specific way. Like I want to make it move by steps every X seconds. So I kind of want to go like this, just move the seed. But we don't really like each state is being teleported in its new state, as it's not being, the values are not being interpolated. So let's just add at the end of our first merge a lag, which will break everything, and let's click on lag per samples. And now that you see, each time we'll change the seed, we'll get this cool animation. Superb. Let's create a bit of automation to do that process. So the LFO, let's put it on pulse. Let's rename this seed, and let's have it move once every 2 seconds. Let's count. So let's make our seed increment through time, and add a null and null seed. Oops. Click on the viewer active, and let's bring this in the seed. Cool. Okay, then the last step for us to do is color. So color is a bit tricky because we don't have we can't influence like with a constant in the same way that we would do it with a geometry comp. So let's add a point SOP. And keep color is going to be add color here. Okay, so let me just copy a fetch stamp example here, and I want to do fetch stamp. I want to call this red, so not just R, with a default value of 1. Let's copy this 3 times. Red, green, and blue. Okay, cool. So the good thing is our red, green, and blue are already here because we've prepared it earlier in the setup. So it's just being piped in the whole in this stream and going directly to the null instancing. So the only thing that is left is to create 3 new attributes here. So red, green, and blue, and copy this. And once again, be sure to call in the right value that we want to call on. Red, oh, this one has to be green. Red, green, and blue. Cool. So in my test, I'd like it when this was fully red and this was fully white. So right now we have our colors and all this is moving beautifully. I'm quite liking all this. So let's go to the render setup. Our frame rate is okay. So render setup. Let's add a geo at the end of the stream so we can render the whole thing out. Let's call this geo pattern. Okay, let's take a constant. And let's drag it on to the materials. Okay, this can be closed now. Let's do a little render setup. Okay, we're going to stay in the 720 by 1080s to maintain the right aspect ratio, because 720 by 1280 is in 9 by 16. So we have the same aspect ratio than in our patterns earlier. Beautiful. Let's add a camera, and this is a very, I think, useful trick. Is when you're only working in 2D as we are now, let's put our projection view in orthographic. So orthographic means you don't need any depth, so it will not render any depth. So and that's another very useful trick of the aspect ratio, is to put the aspect ratio as its ortho width. Okay, so this is strangely very close to reality. The only thing we have to do is change the ortho origin to bottom left, and look at this. It's like perfectly set up. This is wonderful. This is one of my favorite tricks when rendering something in 2D, is to be in ortho width with the in orthographic with the ortho width being the aspect ratio. Let's add a null and call it BG. And let's just, with middle click, zoom into it and just bring it a bit further so it's not too much in our faces. Cool. So one thing I really want to be able to do is have those little intersections. Okay, so let me do this by scaling up the P scale, not just going from 1 to 0.5 to 1.1, but maybe up to like 2.5. Yep, that's too much. Well, is it? Yeah, it is. I think it is. 1.8 maybe. Okay, maybe something like this. Also, this is kind of too, you know what, we'll do modification in a second. We're not seeing the overlap right now. We can change that by going into the comment page of our materials, and in blending, let's toggle this on, and destination color, let's put it in destination color, and boom, this appears. So right now we get the intersections. Now let's find a way to have control over them. So what I mean is more like to isolate them. So the blending function is add. So the value of the alpha, which is by default 1, is being added on overlapping pixels. Okay, so if I have an instance and another instance overlapping on it, the alpha value is going to be of 2. The only problem is in by default tops are going to be in 8-bit. So let's just change this just for like this render top only in 32 bits. Let's grab a threshold and let's threshold the alpha, and anything that is higher, let's say that 1.5, and here we have the overlaps. Cool. This is cool. So this can already be re-put in 8-bit here, and even here we can add a transform. Whoop. Sorry. Whoops. A transform here, and put this back into 8-bit. Not a necessary step, but a useful one. Okay, then so this, let's take a constant and change a bit the color. Let's constant color here. Let me zoom in. I want to have it like in black, like almost black, like a gray. Okay, we're not seeing anything right now. Let's add an edge, which can be, I think, white. White is going to be perfect. Have it on top. Okay. And then let's use a comp, or you can only use like a under or anything, and put it on top here. And under, I think, will be the right one. Yes. Okay, this is looking pretty fine to me. I'm gonna add another edge here, I think. And this time I just want it in white. Yeah, this is kind of the look I'm going for. Oh no, this one I want to have it in black. This kind of have like the opposite. Okay, cool. So next thing we can do, so be careful in this setup with the numbers of samples you have. Once again, quick reminder, this is not the best for real-time or large scale particle systems. I want to add a noise because this is too straight for me. So by default, the noise is gonna add to its input values. So let's take the offset down to 0. And something maybe like this. Something maybe like this. And then all this is totally for interpretation. Let's pump this up. Let's bring out something that we will like. Maybe a little less. This, and now this a bit lower. So all these are custom things you can find out. And then we could maybe make those move along the x-axis or the y-axis to have like an infinite loop. And I would say that mostly we're there. I mean, there's a ton of things we could do to make this better, but I mean, that's pretty much it. Let me just put a background behind it. I don't even know what background this is. Let's hope I don't mess everything up, but I don't know, something like this. This could be fun. So I guess that's pretty much it. Well, hopefully you'll do something with this, and if you do, please share it with me, let's say on Instagram, and I'll be happy to repost it. If you like this tutorial, please leave a comment or a like, and tell me what you'd like to see next. And until that time,